So no, Asha is a subset of that. So it's actually part of this talk. So I think that we're all gonna learn a bit here about that. But okay, so let's get started. A lot of familiar faces in the audience. Interested people. Good, good. So it's gonna be developing for the Nokia Asha Software platform. So I'm not sure how much of you already know about it. So who has developed anything for a Java ME in general? Okay, so some hands in the air. Good. There are people familiar with it. All right. So just to be on the right page with this, let's see. I'm going to say a few words about what this is in general, a few words about the developer offering, a few introductory remarks about the UX, what you should be aware of if you are doing applications for Nokia Asha devices, and of course a bit of a demo with the tooling, including the IDE and the emulator. And perhaps the most interesting part at the end, if you are a developer, some tips and tricks for optimization, which might not be just for Asha. I think that they are equally valuable if you are doing something on other platforms as well. But there was this question of, is this Series 40 or not? So Series 40 is, it has its history. It started a long time ago. First device was 1999. It was a 7110, which is not the Matrix phone. It looks like it, but it isn't. But so that really doesn't mean anything in terms of age, because Linux is actually 8 years older. So just to put things in the right ballpark, and QNX, the base for BlackBerry OS X, is actually, I think, something like 30 years old. So everybody has a bit of age in the industry. So it's just the question of what you put on top. So what happened since? A number of devices have been sold, and that number is actually surprisingly large. It's 1.5 billion devices running Series 40 out there. So it's something that is a very, very serious user base. 650 million of those are active and connected by data networks. So that's the audience that you can actually target with your applications. 650 million people, and you are not that many in this room. It gives you a very good Eskimo to seal ratio, I'm just saying. So, in other places, it would be a lot worse. And the fact is that freemium and ads do work. So the classic model of I give you $1, you give me an app, the premium model doesn't. So this is mostly sold in countries where people do not really embrace that kind of exchange, but freemium and ads do work very, very well. So what happened in the meantime? The world changed a bit. You see on the streets devices and things you didn't see previously. So the world moved on. So we did some changes here. What is this new Nokia Asha? So now we come to the story of how this ties into Series 40. Well, there is the Series 40 hardware adaptation, which is a good thing, because this means that this runs on very, very, very modest hardware. We don't really need several cores, gigahertzes, and gigabytes of RAM. We can do it with a lot less. So on top of this, we got a bit of a smarter phone middleware. If you heard, Nokia purchased the smarter phone company a few years back. So this is providing us with the middleware. And finally, there is a swipe UI on top. So this is what makes it look Nokia UI, or like many of the other previous Nokia platforms that you might have encountered, like Migo or Symbian. All right, so let's take any questions, by the way, regarding this. Yes?
Maybe this should be a question later, but the applications we create using do they work on the older Asha platform?
Yes. So Java ME would. So as they say that when there is not much change, the good news is that also that there isn't much change. So the Java ME as standard as such has not changed much. So unless you are actually using hardware or APIs that are not present in those devices, yes, you are even binary compatible. So you create an application with the new SDK and it will run on very, very, very old devices, provided that you support, of course, the UX and all that. Okay, so but now that I mentioned UX, so what is the news here? So I don't know how many of you have actually seen an Asha 501. So it's a very nice handy little device, very sturdy, with Gorilla Glass and all that comes with it. So I like it very much for travel, not the least because it lasts 40-something days on a single charge. So it's always a good thing when you're on the road. But it also has some changes compared to earlier devices. So it's more aligned in terms of it has like a single button, which is a back button. It's not a go to your home screen, it's a back. So it always navigates back. And the other change that you have here is, of course, the screen changes. It's a QVGA 3-inch screen, and this is something that will characterize the family going forward, because this is just a first of the family. So it's definitely not going to stop here, and real soon, TM now, you're going to see more of these coming at more affordable price points also, and also in sort of sexier hardware as well. So this is a mid-range device in terms of the new Nokia Asha family. Just keep that in mind. The full touch devices, how many of you have used full touch devices? Okay, so there is some difference. So the aspect ratio is slightly different. We have a little less pixels, however they are larger. So the screen area has actually increased, and that makes it a good thing, I believe. So it's always better to have a larger area than just the raw pixels which you cannot make good use of. Because that's what this was about. So the buttons went away. So the options menu is brought up with a swipe up, so it doesn't take any screen estate, real estate up from the screen, and also like header bars and all that stuff went away. So that 3-inch screen can actually hold a very decent amount of things on it, which is good. And this is how the structure looks like. So when you have the phone in a standby mode, like this, you have the glance screen, which is the Nokia basic stuff. And of course, on a double tap, you can do that on the back or the front of the device, doesn't really matter. It will wake it up, and you can continue from the lock screen. Of course, you swipe away the lock screen, and then you get your home screen or the application that you had running. Now, this is where your applications as software developers live. And there is only one of them. So there is no multitasking here because of the amount of memory and CPU used. It doesn't make much sense to keep tons of stuff in the background, but I will return to that in more detail. Any questions regarding this setup? All right, so instead of the multitasking screen, we actually have the fast lane, which is a history of stuff you have done. This is the applications that have been started recently. This is the URLs that were visited recently. So everything you did, it's more like an activity log kind of thing rather than a task manager. And in most cases, I find it actually pretty good. So it's very close to what you would want, because you're usually returning to things that you have just left or have opened recently. But let's build those apps, right? We have to start them from somewhere. What do we do that with? Let's see the developer offering. First of all, there is the Nokia Asha SDK 1.0, which is no longer a beta. There is actually a real release out there now, so don't worry, you can use it and it's all good. And of course, it's Java ME based. Then, if you happen to be, for some reason, a web developer, there is still the Nokia Asha Web App Tools 3.0, which is, I still have it close, yes, sorry, which is a tool meant for web developers. It's using or is powered by the Express browser, so you do have to be online always to use that, but it allows you to write web applications. It's not HTML5, but I will say a few more words about that later as well. And finally, if you are completely sort of afraid of any type of coding, there is the Express Web App Builder, which of course generates this web app for you based on existing content. So if you have an RSS feed and you want just to list things, then this is, I guess, the simplest approach. So as I said, one application at a time. This is what makes it possible to have it, fast and zippy. Because to be honest, if you take a look at the specs, then some people are surprised, like, how can this even boot with that amount of memory and megahertz and stuff, much less do 30 FPS and such, because it does. I will invite you all to come here and witness it firsthand, because people said, wait, this is kind of like, it's just not that spec. I would think it's sort of either higher spec or it's slower, but actually it's not. It's very nice, and this is one of the reasons. So only one user space application at a time. Okie doke. Then what do we get with the SDK? We get, of course, an Oracle-based Java ME implementation. So if you have worked with Series 40 previously, you might have encountered something else. It wasn't an Oracle one previously, it was an ARM licensed one, but now it's Oracle, which is also a good thing because it now gets the hotspot stuff for free, so it's a bit faster in most use cases. It also has a number of new APIs, and that's, I guess, something that I will also say a few words about because it makes it closer to a smartphone, or it is becoming a smartphone, as they say. And of course, because Nokia is a big company, it has tons of these additional libraries and units and all that's provided with it. So in this case, the here maps, the lightweight UI toolkit, and all the things that Nokia does are now part of a bundle. So it's not something that you install additionally, hunt on the net or anything like that. You just go and put it up. There is also the Tantalum thing, which I will point out, which is a fairly new thing here. It is a little library. It's not like a UI toolkit or anything of the sorts. The benefit of that is it gives you, it's a sort of a toolbox for a number of things. For managing memory, for having a common code base with Android, yes, you can have actually common core logic because Java is that close. So unless you used some language features which are not available to Java ME, it can actually work. And there is, of course, on-device debugging, which is at this point only Wi-Fi, but still, it's for those heavy cases when you just don't know what's going wrong. So this is the unpleasant part of the conversation, as they say. So being Java ME does bring some baggage. So yes, there is a number of JSRs, so the APIs that the Java ME world is working with, because you know that's the every OS talk here starts with the others were not open enough, so we made one too. So Java kind of started this way too. There was the Java community process, and then people submit the JSRs, and then somebody accepts them and says, yes, this is what we want, and then nobody implements them. So a bit like HTML5. And in that regard, what we have here is a set of APIs, which are the JSRs, a set of Nokia APIs, which allow you to make something which is very close to the native applications running on the phone, with the limits of the memory. So there is a limit there. And that's something that you have to be very, very much aware of. So jar file size 5 megs, that's how big your app can be in one sort of single shot. There are workarounds, and you should use them, and I'll explain why. And there is a limit of 3 megs of RAM. This is actually more for your Java heap. So this is not a device memory. This is how much you can sort of, in a worst case scenario, be able to survive on. Let's put it this way. In a realistic use case, you will have actually more memory available to you, but that's not something that you can count on. And I see funny faces in the audience, and I think this kind of illustrates it pretty well, covers the range that I see here. So, so yes, 5 meg application size and 3 megs in memory. So yes, this is a resource-constrained environment. Yes, very much so. But there's a silver lining. That this means that we don't tolerate any sloppy coding. So again, Eskimos and seals. So if you have a good application, it turns out that you can actually do very interesting stuff because your memory budget is something that you can work with. It doesn't count towards the system memory use. So if you use system libraries, that doesn't count into your memory usage. And so if you are a good coder, then you can actually turn this into your advantage because the slow apps just go away. Nobody cares about those. Any questions? Okay. So we have the Nokia ID for Java. This is actually Eclipse. So it's a custom version of Eclipse. It's a bit beefed up. We have some additions to it. So there is an emulator, of course, for the devices. There is a number of templates which allow you to start very quickly and easily and see just how you should structure your projects. There is an application descriptor editor. So all these funny Nokia-specific Java ME attributes can be set now very easily from there. And there is a device SDK manager which allows you to choose, just which devices you want to develop for. So let's see first, I guess, the emulator, because that's the easy or cheap way to practice. You don't always have the money to buy an airplane to, do the target practice and everything. So you, of course, do the emulator. I think I can actually show it now. Is it on screen? No. Let me try. Let me try to do some magic here. I wonder, will it blow up if I do this? Sort of. But in any case, you can see the emulator. I will hide this part away. So this is something that is very close to what you would see if you had a real device at hand, or what I would be showing you if I had a document camera. This is a build of the firmware, so if you are going into settings, menus and such, you would actually see here things that would be on the device. So everything that you would have there is also working on the emulator. So swipe, all that stuff, the options menu from the bottom, and yes, so all these things. This is all a very, very useful way of checking things out, and given the Java ME heritage, it's actually fairly easy to work with this, so it actually is close to the device. It's not good for, of course, performance measurements. So if you are trying to discern how quickly something will run, you do want to try it on the device, and this is especially true in terms of media playback. So if you are playing back videos, music, that stuff, always trust the hardware and not what the emulator is showing you. There is a number of things you can do. Also, let me just get back to this, and let's see what I end up with. Well, that was close. It's nice, but not the presentation. Still not the presentation. So I will press a few more buttons, and back we are. Okay, so what can we do with this emulator? It speeds up the development cycle. We don't have to go to the device. The deployment is actually fairly quick. The emulator itself starts slowly. Don't close it between runs. That's a very, very sort of important advice, because it will take a minute or two to start up. But once it's actually running, it's fairly good. You can use it to take screenshots. People always ask me, like, how do you put things on the device and then take screenshots for them? Well, the easiest way is don't do it. Just use the emulator for the screenshots. That's going to be pixel perfect, and you can even have a 2:1 zoom, so it's very, very telling, especially when you're doing pixel perfect designs. It can also use a customized touch input, so it simulates multi-touch. You can do the pinch zooming thing. I can show you as well that. Pinching is very hard when you have a microphone in your hand, so it's going to be something I do later. It also has modules for sensor emulation, so you can flip around the device and see how, for example, accelerometers work. And it also hooks into your webcam, so you can actually use your webcam as a camera if you want to check out or take images and such. It's also very easy to copy things to the emulator. So if you want to just have some images or files copied over, just put it in the file structure of the emulator itself, and you don't have to copy things over to the devices. And of course, when the emulator is just not cutting it, then you of course can go to the on-device debugging, and then you can find those nastiest bugs in the real hardware, maybe even. Yeah, I don't know if you can actually see what this is. Yes, you can. But if you did everything right, so you went, installed the tools. It's not that hard. It's yes, okay, finish. Made your first project and run it. You are, experiencing the joy of the first successful run. Then you have a running series for the application. I would be switching over, but it takes a while, so I think I'm gonna go through the whole story here and then do the more hands-on parts at the end, because otherwise we would be losing too much time on the switches. But if there are any questions, not yet, all right. So there was this question of compatibility. So the visualization changed. As you can see, this looks very much different than even full touch, and of course very, very different compared to touch and type or older series for the devices. So the good news is that the APIs remain largely compatible. So this was more of an extending the platform, and this really is a platform approach, and it's now an updatable platform. So previously it was, you got shipped with the device. Maybe you had some fixes, but that would effectively mean flashing the whole thing. There was no real possibility of incremental updates. That's no longer true. So now we have like a proper update mechanism in place. So when new features, APIs, devices come with new versions of the Nokia Asha Software platform, these will be getting to the 501 and any follow-up devices that would be coming, which is good news. And this is how it looks like. So there's a number of APIs. And you don't have to read it. It's very small and all that. The idea here is that the lighter boxes are the ones that were previously present and still present, and the black ones are that are new. So as you can see, the stuff that was there is pretty much still all there, but we have some extra stuff. And what's that extra stuff? Well, some of it is actually not that new in the terms of that this was previously possible only if you were signing for it. So things that were possible only with manufacturer domain signing, you had to have a paper exchange with Nokia, some signing going on, etc., maybe even some money if it was the manufacturer domain, but still it was effort. So these things are now very simple, and you use them just as you would in any other platform, so standard public APIs and such. There are some new ones though. So of course some things were done differently in the old days. So we said that there is a single application running, and then you of course are swiped away, so then you're not running. So what happens? How do you get awoken? How do you get data to your application? Well, there are simple low-tech solutions like here. So you pay somebody and they tap your window in the morning to wake you up. But we actually have something a bit more technically advanced, the Nokia Notifications API. So this is a push-based notification. It's actually running as a system daemon. It handles the messages through one shared channel, so it doesn't matter how many applications are listening. So it doesn't mean an extra toll on the battery because you have 100 apps registered for notifications. It's also good because it's optimized for battery power. So it actually goes down to the level of carriers, individual carriers. So it's very, very efficient and doesn't really take off anything almost of your active standby time. Of course, if you have actual data flowing through, that's a different thing. But the usage of the API itself is very, very sort of battery friendly, and it has a custom payload. It's not large, it's 1.5 kilobytes, but that's just to avoid being bombarded by images and clogging the whole notifications queue. So if you need more, that's again not a problem. You as a payload just deliver a URL and then you're good to go. So it's a very, very nice and convenient way how to get your application back. When you receive a notification, it will be shown on the lock screen, so you just tap it and then your application comes to the front. If you skip, then of course it will be still there in the notifications bar, so you still can get invoked. In other words, it's just an extra way of how to get to your application even though it's not running. Any questions regarding the notifications API? All right. And then there is the in-app payment. And this is something very easy and very interesting. Because the truth is that there are large parts of the world that they have a lot of different devices being sold at. So you can see that this thing applies to a lot of Nokia devices. This is not just the Nokia Asha Software platform. This is also for the full touch devices, 6th edition, Series 40, and all that. So it's a very, very large coverage in terms of devices and also countries. This is actually a fairly outdated one. I hope that I will find something newer, but unfortunately nothing I can share at this moment. So this is April 2013, and I assure you that in the past 6 months there have been a lot of countries added to this picture. And do you know what the key here is? Do you see something odd? Why is this different than any in-app payment system? Any guesses? Okay, let me help you. So what do you think, how popular are credit cards in, say, Pakistan? I think that's one, yeah, they're of the supported countries. I can pick another one, but come on. I know it's still morning, the coffee break is after this, but you have to work for it. So the thing is that this is carrier billing. So you don't need a credit card. In tons of countries, I mean, in the Western world, you are kind of used to that, yes, especially in the US, you would say, oh, everybody has one. But there's a lot of countries where there isn't. And even in the case where it's a country where credit cards do exist, there are use cases where they are just not convenient. Can anybody name an example? Yes? Well, annoying. Punching in numbers can be annoying. Yes, I also have maybe some beef in punching in numbers, which are credit cards into random hardware, as we heard in the banking session, can be, eavesdropped on fairly easily. So that's one thing. So some people might decide that they just don't want to enter and use credit card numbers, because that's sort of like a bigger caliber than just for a €1 payment. And the other thing is that if you are underage, so not everybody has, I guess, here children who are of that age that they want to buy things from app stores, but it's actually a problem. So nowadays you would have to come up with various workarounds and kids corners and modes so that children wouldn't buy tons of stuff using your credit card, so that you would figure out how that sort of ends up with. And this is also a very good answer to that. So all in all, it's a very, very nice and convenient solution to cover a very good sort of payment options all around the world. Again, this is an area which is not covered probably by you currently. So chances are that in many of these countries you're not really earning money if you are relying solely on credit card payments. So just thinking. And since I mentioned that, this is really a global thing, so the Ashas are really sold all over the world. The 501 is rolling out as we speak. So internationalization is one of the core features. So there is a new JSR. So it's actually a JSR, so it's not a Nokia invention, but just an API which allows you to localize and internationalize applications all that much easier. So you get the format, date, time, all that stuff for free, even sorting. And yes, it can be very annoying when you have funny characters. Polish has them as well as Hungarian and many other languages. So, when you wonder, like, okay, so this is not a Latin classic English alphabet letter, so is it at the end? Is it at the start? If I sort by bytes, it can be very, very tricky. In any case, it gives you that for free as well. Okay, so we established. Any questions, by the way? Or any APIs you have questions about which I didn't mention or just skipped over? Yes? You will get an exception, obviously. So if you don't handle an exception, the question was, what happens if you're using APIs which are not present on older devices and you run the application on the older device, right? So first of all, there is a number of methods you can check whether the API is present. And they range from checking system properties. There is actually an is method supported call in some of these. And finally, you can go for a class 4 name and try to instantiate. And then if it doesn't, that means that of course, it's not present on the device. So Java AMI is fairly OK in terms of fallbacks. So you can fall back gracefully if the API is missing. So the system, of course, doesn't do that for you. So if you try something that is not present and then you don't handle the exception, then you will, of course, fall on your face. But yes, very much possible. All right. Any other questions? There was...
The carrier billing, does it work with prepaid accounts too in general?
Absolutely. That's one of the main reasons you want carrier billing. So we don't. So the key with carrier billing is that you don't care how the money gets to the carrier. Whether it's a prepaid account, is it a postpaid account, is it won on a lottery, or how they are topping it up with money, with milk, whatever. It doesn't really matter. So the point is that the carrier and the client resolve their monetary transfer, and you just get the end result, the income from the payment itself. Yeah, you say that you say you have 20 euros or the amount of money on your phone. If you run out, that's it. So learn to manage your resources. You're welcome.
Do you need Windows for the SDK or other platforms also?
So officially, it's only a Windows 7 and 8 supporting SDK. If you want to code for the Nokia Asha SDK, but there are actually very, very easy ways to get it running on Linux and also on Mac. So yours truly has actually developed and written a few scripts which make this fairly transparent. So you can have and use a native IDE. So you can start, for example, on Linux NetBeans or Eclipse, so the Linux one, and just call the toolchain or the emulator which is running through Wine. Sorry?
You just said that emulator will run through Wine.
Yes. So, but that's just the emulation part. So it's actually not the whole thing, not the whole SDK that is running through the emulator. So so in my experience, because previously since I also use a Linux machine as my main development machine, I was previously using VirtualBox, and it's tons faster than going through VirtualBox. Any other questions? All right. So now getting to the deeper, more technical parts of things. So if you did Java, you know that there are or Java ME, let's put it this way, three basic UI development approaches: Canvas, LCD UI, and LWUIT, or Lightweight UI Toolkit. I will say a few words about each of these. So the first option is Canvas. Canvas is good because it allows you to create a custom UI. You own every pixel. You are responsible for every single pixel. So it always comes out as you want it. Unfortunately, that means that you are responsible also for drawing every pixel. So the system literally does nothing for you. So you get as far as getting a status bar, and from there on, it's all yours. So there is no buttons, there is nothing else. Canvas, you draw. So this is most suited for games because of this. And the other benefit is, I guess, that this is the fastest approach. So if you're really, really concerned about speed, you will go to Canvas. However, normally, when you are not doing games, you will have some sort of UI, input elements, buttons, forms, and all that. And there is a certain platform native look and feel. So you want to be in line with that, because when the user sees something they kind of don't expect, then it's like, okay, so is this really supposed to be here, or is it just some kind of ruse? So for that, you have two approaches. One of those is LCD UI. LCD UI is the simple thing. It gives you high-level components. So you get your button, you get your splitter, you get your little picker and all that. However, there is no customizability. So you literally say, put a button here. You don't get to say how the button looks like, whether there is 2 or 3 of them in the row, what's the color of it. No, you just can say this is a button. So it's super, super simple, and you cannot customize it except if you decide to draw your own items, which is a kind of a hybrid solution, and actually is probably the most performant. But that's like if you are really, really advanced. Normally, the development pattern I see in developers is that they start with Lightweight UI Toolkit, because that gives you the most options, as we will see. And then they say, well, this is not really working for me, so I will take the quick one. So let's go LCD UI. And they say, it's too simple. And finally, they end up with LCD UI with custom items. So it's always a trade-off, depending on what you want. But just to illustrate, when I said that LCD UI is simple, this is all of it. So this is what you get. These are the elements you can choose, and that's it. And normally there is very, very little customizability, as said, not even like button color. So there is benefits to this approach and there is drawbacks. So the benefit is that it's a very simple UI. You can construct a UI very quickly, see how it works. It will be zippy, but it's really not about like giving an empty piece of paper to your designer. That's very, very far from that. You will end up with a sort of as a predefined layout sooner or later. To fight that, you have LWUIT, the Lightweight UI Toolkit, which is something, at least in approach, more in line or similar to the modern UI toolkits. So you have more components, more customization. You still get the look and feel. You can color your buttons. You can choose up to 6 different colors. So it's almost whatever you want, right? So anyway, it allows you to get at least a somewhat branded look and feel. It's also in terms of logic. So layout handling, animations, transitions, and all that stuff, it's also a lot closer to other UI toolkits you would see on other platforms. However, it comes with a price. So there is some trade-off here. First of all, you have to include it in your jar file. We said already that it's like 5 megs, so it's not really that you have all that big of a budget, and a few hundred K will be lost on LWUIT if you do this. And the other problem is that LWUIT is the slowest of these options. So while it gives you a fairly customizable look and feel, it does mean a trade-off in terms of speed and resource usage. Any questions? Okay. And there is the web app tools. As said, this is an Express browser powered solution. So it's this proxy browser. You have to have your data connection on for this to work. The good news is that it's HTML, yes. JavaScript stuff runs, yes. We have a camera API for it, yes. And so there is a number of things you can do, but do not expect it to be like an HTML5 kind of approach. So you don't get Canvas, you don't have anything of those sorts. It's really just a very, very quick way of getting into the web business and working on from there. Of course, you have a simulator, so you can check how it looks like, and you can deploy via USB and all that. It is backwards compatible, and it's also styled automatically. So it means that the exact same binary that you use on an older Series 40 device and on the new Nokia Asha will look the right way. So the options menu will be a swipe up on the new one. It will be an option button on the old ones. So all that mapping is done automatically. So there is nothing you have to do in terms of the styling. So it's 100% compatibility for the web apps from older devices. This is very, very nice. Any questions regarding the web apps? Okay. How many of you are web developers here, just out of curiosity? Are mainly web developers. So it's okay. So that kind of killed a few hands there. All right. But as we know, testing is best done on devices, preferably somebody else's, because nobody likes to flash their own, right? So for that, we also have a solution. And that solution is called the Remote Device Access. So somewhere in snowy Finland, there is a lab with rows and rows and rows of devices which you can connect to over the web with a little Java client, and you can actually stream this content off the screen. So you see their file system, you can drop files on them, and these are actual devices. So this is not an emulator. This is something that you are working with an actual hardware. So whenever you're wondering, there is another device that's maybe different, it's maybe not, it has a different screen resolution, whatever, then you can always try out and see how it looks like. So that's a very, very convenient way. It's also completely free, so go there, use it, have fun. Now it also has obviously the Asha 501 included, so you can test that out if you cannot buy it in your country, or you decide not to buy one in Poland, because I hear you actually can buy one here, which is good. And that would be a quick intro for the Remote Device Access. Any questions about it? Yes?
Do you think Microsoft will continue this program?
The Remote Device Access? Well, obviously I'm not a Microsoft employee, so I don't know what they will do or not do. I would assume so, because it is useful, yes.
The Microsoft presenter yesterday also said to use this thing, so I suppose that
yes.
may mean a lot.
Yes, so especially if you're targeting older Series 40 devices or full-touch devices, so it's usually a problem to run across these. So especially if you're doing tricky things or you need like variants which are not available, so like if you need to try something and verify whether it works on a dual SIM setup, these kind of things. So that's just really tricky if you are trying to do that on an emulator or anything else. So that's why I think that this, at least in that context, will keep on working. All right. Any other questions? Okay, so on to the fun part, performance optimization. Because as said, we are resource constrained. We have to do with whatever we have, and we may have to make it as fast as we can. So as the gentleman here puts rockets on his bicycle, well, hopefully we'll not do anything as dangerous, but hopefully as efficient as it is. So let's see. So why do we optimize in the first place? So obviously you can do things in different ways, different techniques lead to different outcomes. Some are better, some are faster, some are just using less memory and all that. However, the focus nowadays is the responsiveness. So, it doesn't matter how quick it is as long as it appears quick. So the numbers on the clock are less and less relevant. It's more the eyes, or at least what you believe that your eyes are telling you is what you should be focusing on. And one of the reasons for this is that we actually have some things hardwired in us, apparently. That's what at least psychologists say. So if it's under 0.1 seconds, then we kind of feel that it's instantaneous. Yes, we might, some of you might see that, oh, there is a frame dropped. Ah, I saw you. So, but in general, people will perceive 0.1 seconds as something that is very zippy. So I clicked and something happened. So it was very good. And the thing is that the something is the key here. It doesn't have to be the actual result. So as long as something is happening, it's good. 1 second is another limit, which is when people realize, like, okay, so I'm waiting now. So this is something you want to avoid. If you are getting to this stage, then you have to be clear that you have to include this in your strategy. So handle this. How do we handle these kind of timeouts when we are over a second? Any sort of examples?
Using
An animation, right. Yes, one animation. Or for example, what would you do on an application startup? Splash screen, okay. So by the way, so one thing about the splash screens, I think that's sort of a largely misunderstood category. So the splash screen is the lazy man's way of saying that I'm busy, but I don't really know what to tell you. So here's the screen, take a look at it, and I will be off doing something else in the meantime. So there are just usually more intelligent ways of trying to fool the user into thinking that there is something going on, whereas a splash screen makes it very clear that stay tuned, we'll be back later. So the interactivity is lost. But yes, the splash screen is certainly one way of just doing something. It's tons more better than not doing anything. A splash screen can be bad if you don't need it. So there are people who have this sort of agreement that, oh, we have a game, and it's produced by 2 studios, and we have 5 publishers and 6 supporters, and all of them have to have a 3-second splash screen. So don't do that, please. If it takes 18 seconds to get to your game just because you want to show every friend of yours, not a good idea. And that's the third category here, 10 seconds. So there is very rarely any chance of the user returning if you left him hanging for 10 seconds. You will get red button. It doesn't matter how cute your animation is. It doesn't matter how cute your splash screen is. After 10 seconds, it's, I'm going to do something else. So realistically, unless it's, for example, something as a download, in which case, again, most of them will quit. So you have to keep your downloads short and burst oriented. But how do you find out? What are the things that people tolerate? So do you guess? Yes?
Dancing bunnies.
Sorry?
Dancing bunnies.
Dancing bunnies is good, but how do you know that your target audience is very receptive to target bunnies? Everybody is. That's an assumption.
On Saturdays, replaced with cats.
On Saturdays. On Saturdays, replaced with cats. Yes. For the more scientifically inclined, I will still suggest a bit of user experience studies, so you can see how users react to your stuff. It maybe makes sense, maybe it doesn't. So I know that as a developer, you say, well, this is obvious, this works, it will protect you, it will be handling everything perfectly. And sometimes we do fall in this trap. There is this classic one. I believe that everybody here has seen this. So which line is longer? How many of you think that the upper one is wider than the lower one? No hands in the air. How many of you think that the lower arrow is wider than the upper one? No hands in the arrow. How many of you think that the 2 arrows are equal, actually? Tons of hands in the air. Yo! Well, people have met this. Here's another one. In the same vein, how many of you think that the white circle is larger than the blue circle? Nobody. How many of you think the blue circle is larger than the white circle? Nobody brave enough to admit. And this is the problem, that developers tend to be too smart for their own good sometimes, that I know what the user wants. I know, I see it. This is going to be slow. This is fast. This is good. So, that's why we do user experience studies. We sometimes assume things, and sometimes, they just seem different than what they really are. So, keep your keep your things in check, because otherwise you will end up with conclusions that you made and not your users, and that's never good. All right. So we are working in resource-constrained environments. So this was a 3-hour flight from Sao Paulo to Manaus. And this was the, I was asking, like, I was hungry, and I was like, oh, there's going to be food on the flight. Good. That's the cheese sandwich I got. There is cheese in the corner, yes. So, you know, this is a resource-constrained environment, so we have to deal with things here that, you know, make do. So we will have to make it, you know, as at least as a perception that it's fast. It might not be really, but, you know, we just have to make it appear fast. And what you believe is more important than what you are actually seeing. So if you think that things are fast, they will say, you, yeah, you're fast. No? So you always do visual updates to acknowledge input. It doesn't matter if you processed it or not. So you can, you know, always come back and then signal it another way that something happened or that there is something going on. But, you know, immediately, as long as you have something, some kind of way of, you know, determining the user interacting with the phone, do it. And this is something that is very hard to grasp at first, but very important. Draw when you can, not when you are ready. So, you know, sometimes say, well, but I don't have any sort of data. Then you cheat. Don't cheat too much, so don't mislead the user that hey, this is, you know, but I have saved something when in fact I haven't. But, you know, you can always place things into different places and optimize the flow of the interaction so that you know, you are actually drawing things at places and people think that, well, this is quick, this is fast. Let me give you an example. A save dialog. So you press save, it's a large file, it will take a while, and then you pop up a dialog and say, user, are you sure you want to save the file? User takes a look, presses yes, and you say, done. It took me over a second to save. I cheated. How? Immediately after they pressed OK, it was saved. So I started, yeah?
I was saving during waiting for the user to answer?
Yes. If the user says no, deleting is very quick. So I can, you know, discard, nobody saw me do it, I didn't do it. So, and if he says yes, I have it written, I was quick. So the user has a perception that I'm able to save, you know, large amounts of data. And that's more, you know, yes?
But there's one risk. You override the previous copy. And user wanted the previous copy.
You save it in a different name and rename it back. So again, yes, this was just an example. So of course you have to handle all the outcomes. The point is, don't get bogged down by having to make a choice based on the user input. You can carry on all of the alternative inputs and handle the possibilities, and then just confirm the right outcome. So that's more like, you know, how you engineer your interaction with the user. So it's not about, you know, this saying that this is a sequential. The user does this, I do that. The user does this, and I do that. So we have to be more creative than that. So right, and speed because of this is not throughput. So consistently, of course, we can not save, for example, large amounts of data with an iBlink, but we can do it in a tricky way. And you know, one of the way of doing this is, of course, as in this case, is it's actually parallelizing. So one core does not mean that it's one system. So yes, these are not dual, quad, whatever core, you know, system on chips in these devices, but still, there are subsystems which can work in parallel. So the file subsystem, the modem, the networking, all that stuff can, to an extent, work in parallel. And you need to do this to unleash the maximum potential. So yes, please do use threads. And in terms of the Ashas, you will want probably to use around 4 to 5 threads in total. So preferably have a worker pool, so spawn the threads up front. Don't waste time, because spawning them also takes a bit of time. So, you know, do it up front, and then just reuse these threads so that things seem zippy, at least, if nothing else. However, you know, this seems like a good advice that, okay, threads, and I just start threads every time I do something. And then, you know, then you end up with these really, really long-running threads, a lot of them. And then in the end, you don't know what's happening. So you just see a lot of threads. None of them are really moving. So you're not sure if this is how it's supposed to be. It's very hard to debug. It's fairly complex. So it's just, you know, something that is very hard to deal. That's why you need to make clear that the threading is more like task-oriented. So keep it small. You know, it's one single network interaction. So don't spawn another thread for all of them, etc. And while I'm working on or speaking about networks, here's also an example how to make things appear zippier. So how do how would we make a network operation feedback look like? So when somebody presses a start download button, what would happen? So the actual flow, so what happens on the technical level is that, of course, network connection is opened, there is a web request sent, if this is, for example, an HTTP request, then we have a response, the server says like 200, we're good to go, then some data starts flowing in, that gets finished, then we parse it, and then we display it. So there is a number of steps and things going on. And so if we just want to display this to the user, we said that we want to the user post it, what would we do? There's going to be a dialogue, but what would we put in the dialogue?
Pinky bar.
Yes, for example, for the entertainment value, definitely. Yes, a progress bar. But what would you display on the progress bar? So if it's let's HTTP download, what would you put in the progress bar?
Just moving the dots without any information.
That's not good. User likes to see that the percentage that whatever they are doing is going somewhere. If it's dots, like, is this 3 seconds? Is it 50 seconds?
Are used to a way how Windows displays.
Not necessarily. So the Ashas are often known by people who either don't actually use Windows or have never seen one, maybe in some places of the world, and that's not really a paradigm. So there is a very conscious shift when you say, and it's a funny thing because people are actually more patient with desktop computers, which have significantly more horsepower than mobiles, and it's kind of a funny interaction pattern. But okay, we are moving in the right way. So here's an example, and you will tell me what I'm doing wrong here. I'll say starting download. This is when I send my network request. I will, because it will take a while for it to get established. If I'm on 2G, especially in the middle of the jungle, it will take probably 3 seconds just to send that packet. Then I will have a determinate progress bar, which tells me how much kilobytes I have downloaded so far. I will parse the thing, because it's probably a huge XML or something, and then I will display it at the results as a list or whatever data it needs to be displayed. So how can I make this look better for the user? I don't know who was first. Okay.
I think it should be just one bar, which starts by being indeterminate while doing the request, and then converts to determinate, and then we just calculate how much amount of time we really need to parse, and just put in the end.
How do you know how much time will you need to parse? Well, I would say that depends on the complexity of the data. So, if you need to do post processing of it, or kilobytes itself doesn't really say. But yes, the direction is I would say good. Do you have a different one?
When you press start download, display this screen with an empty list, put the progress bar on the top of this screen, and then as items arrive, display them one by one.
Perfect, and it would work on any platform but this. So that's the thing, that's what people run into often, that they say that, oh, I have a solution for this, and on iPhone 5s whatever, it works perfectly. But I said, your UI choices are very limited here, so you will have to be very, very careful. There's always this problem, like, I convert my indeterminate to determinate progress bars. How? So I said LCDUI, if you're using that, or even LWUIT, or that's way, way beyond them. So think simple. So these are devices which have, as said, 64 megs of RAM in total. So for the whole system with everything. So not just the application. So you have to be creative to do that. For example, one way is that, of course, you do need to provide feedback throughout the download, not just when actual data is flowing. So we have these 4 stages, and there was a very good suggestion there, so that we start immediately. However, we can cheat our way around and make it a determinate bar right away. And we say that yes, we will make them steps because we know how many of them are there. We not necessarily, so nobody expects them to be linear in terms of like the time that this is happening, but we know where we are in this flow, and that's important for the user. So that's when they know that, is this worth coming back to at some point? Yes, it might be like, jerky, go faster, slower, but that's still better than indeterminate progress bars. Indeterminate progress bars are not good because you lose the sense of interactivity. So whenever you can, avoid them. All right, so we get the progress bar, and immediately afterwards, we get the result. There is another benefit to this. Do you know what? Because we were transferring network data, the user is very clear that says like, okay, so if this takes a while, it's because the network is slow. It's not your fault. So if you say that I'm parsing or I'm converting these, determinate, indeterminate progress bars, or I'm futzing around with populating the list or that stuff, then if it's happening slowly, then it's your fault. It's you who is mangling the data slowly. But if it's, the whole thing is represented as a download, then it means that it's a network. And for the network, people are a lot more forgiving than to your app. So there is another angle to that. Because you don't want to. So I said it's really not that customizable. So you will have no sense of what's going on. When is it done? So it's not that, I put something on top so that it's alpha transparent. Again, that's not how far we can customize this UI. So you can, of course, dynamically populate the list. That's not the problem. But how do you provide right feedback that now this is done? Again, not possible. So always check first. I said, I had the screen all the elements I could position, and as I said, you have to populate your forms and dialogues with those in a very, very restricted manner. So that's, as I said, good because it gives you a very, very standard look and feel. So there is no wondering how this is supposed to look like. But on the other hand, it does come with this trade-off of customizability. So if you want to do that kind of stuff, you will go to Canvas, and Canvas is a time sink, to be honest. So because you just waste so much time drawing, pixel by pixel. Any other questions or suggestions? Okay, file I/O. The thing is that on these devices, especially when you have memory cards, because all of them have memory cards in them, so you don't really know how quick they are. So they tend to be actually fairly slow. So you do not expect to write 10 megs a second. There's none of these users put a class 10 SD card in there. So it's something that is making things very difficult. And this means that your file I/O is something that should be a habit. It's not that I'm waiting for things to pile up and then I write stuff down to my file system. You have to be smarter than that. So you should write things as you go. Obviously in a worker thread, because we don't want to stop the UI for that. And obviously it will have to be flushed occasionally because the file system layers are working that way. And you don't do it byte by byte, because that would make it really, really slow. So in Java ME terms, so that would be like this. So an output stream write. And whoops. Why do you think this is important for me?
Because of the way how MMC controllers work.
Yes.
You have erase block, for example, for megabyte of card. And you will write, for example, 5 kilos. You need to read 4 megabytes from card, update your data, write 4 megabytes back to card. It takes time. On class 4 card, huge.
Yep, it does take a while. So, be reasonable, of course. So don't do it in terms of 1K, because that we can write if there is a immediate need for it, but don't wait it to pile up into megabytes, because then you run into another problem, is that just the amount of raw data itself is going to be large. But why is this writing thing so important? Especially in terms of the state of your application. So of course, we established that you cannot run multiple applications at once, so you probably want to save your state even and such at some point to be able to return. So here's the thing. When you are working with the applications, users are a bit more patient. So there is something going on, I'm working with my device, good. However, let's say that they are leaving. They want to quit your application, do something else. There is zero patience. They have made up their mind. They want to go away. So it's not that, please wait, saving, I will be back and you will be able to do what you want in a couple of seconds. That doesn't work. You get your long press button, kill. and all the precious data that you were trying to somehow save got lost, including your state. So, and on Asha's, this is actually even quicker because the way the interaction works is that it's enough for the user to just do literally this, swipe it away, and your app is getting its goodbye signal, and if you are not away in a second, you are literally killed. So this is why you cannot let things pile up. So if you have things to do, just create yourself a small enough window so that within a second you can get out and save whatever you want and not jeopardize to lose data by being killed when you are not ready. All right. So don't wait, as a summary, don't wait for it to pile up, especially when you are getting your destroy app call. However, another 5 meg jar limit thing. There are workarounds around this. So, and if you're coming from the sort of Android, iOS world, then you are, seeing games of like several hundred megs and such, but it's just the fact of life that, not everywhere can you distribute such big applications, and most of the places this is being sold at, that's not really a good proposition. So there we have a number of strategies how we make files smaller. First of all, obfuscate, always. It actually, even the original intent was to, make somehow code less readable, which in Java is a sort of losing proposition anyway, but still, some people thought it's a good idea, and it was to make your jar file smaller, not for much more. But that's one way to, shave off a few bytes for free. Use the appropriate image quality and size. I always see people recycling Android FVGA and such white VGA imagery in application, then scaling them down, which is completely bogus. So because you don't really have a budget for having oversized images, use the right sizes always. I mean, it's a QVGA 3-inch screen, so it really doesn't really matter much. Also, if you have tons of images, Java.me has a very nice little sprite library which allows you to clip out the individual images. So you don't need to have 1,000 headers superfluous and such. And of course, keep things in the record store. That's your free take it out, because the budget for that is a lot larger. So, and this is actually something that might be interesting also for other platforms. Treat your jar file more like an online installer. So you do not need to include the whole, 150 levels of your game in the first install. It's completely useless. Most of your users will never ever see those levels. So, just put the first 10 or so levels in and download the rest from the internet, put it in the record store. You can put as much stuff as you want almost there. So it's something that is more of an online installer. And there is a reason for why I'm suggesting this. So even if you are under 5 megs in terms of your install file size, you want to do this because small jars mean less failed downloads. I think that people sort of underestimate how many downloads fail during the download, the physical process of downloading. So what do you think? What's the ratio, for example, of download failures of your applications? That's actually a very good guess. So half of your downloads will fail. So users will try for whatever reasons. Maybe they are in a metro, maybe they have a bad reception for some reason, whatever the cost is, maybe they run out of budget or whatever, it doesn't matter. The point is that half of the times people will fail at downloading your app, even if it's not too large. And I was speaking to some guys in Finland, and they were saying that, well, we kind of were not too concerned. We had something like 600-700K application, but then we decided that we don't need some things, and we made it 400K, and suddenly there was a 25% increase in download count. For nothing, for free. So that's something that you should be aware of. Even though you might have a good connection, your users do not necessarily have. So that's one thing. And the other why you want small ones is that your user gets to interact with you sooner. Expectations rise as I wait. I waited 30 seconds to download this. It better be good. So sorry?
What happens with the additional download and data if the user uninstalls the file?
So it will get, so the yes, so you should treat it as removed. But still, so that's something that you can do sort of in the background while you are interacting with the user. Yes?
Can I use own compression in jar file? For example, okay, there is this 5 megabytes limit, but for example, my jar will have 150 kilobytes decompressor, and the rest will be compressed data.
Yes, so as
you fetch the user fetch application, run it, application will decompress and store itself on SDK.
yes, so to summarize, you can modify the contents of the jar any way you want, including any custom, compression mechanisms and such, as long as you don't sort of break the jar and signing process itself. So as long as the all the respective rights and stuff is handled properly, and the format itself is not broken, so it can be verified and signed, it's good. So
is there any limit of space I can take on SD card?
yes. So
Other than
the size, obviously. Yes, so the first limit will be the size. The second is, of course, depending on the file system. So FAT has its own limits. And if you are using the record store, then there is actually a sort of a split in terms of that the record store has 500K blocks, and you can use, I think, 1,000 of them, but that's a number I have to look up. Don't worry. So other than that, you are pretty good. If you're writing to the file system, you can write as much as there is space on the file system. The difference being that the record store does not require user interaction. So when you write there, there will be no pop-up. This application wants to write to your memory card, whereas you will get that if you want to write to the card, obviously, directly. Okay? Yes, there is a big timeout. I'm almost done, but okay. All right. So then one just quick kind of mind sort of workout for the end, just about how we think about memory usage, and that's what probably pretty much where I'm gonna stop here, is how much memory do we really need. So let's say we have a list, contacts, whatever, and let's say we have 1,000 items in that contact list, and let's say we need 1 kilobyte of data for the whatever thumbnail image, the numbers, name, whatever. So how much memory do we actually need to be able to display our list on the device?
60 kilos.
No. 60 kilos was the first guess, but no. 6 what?
Kilos.
No. The picture might be too small, but so obviously the dumb way of doing it is read the whole thing in. That would be 1 meg. But we established that we can probably do better. But the real answer is 8 kilobytes because of the way the layout is. So you have always at least 7 on the screen. There is a 7th popping in. And then, depending on how you discard things, you might run into this problem of having or needing 1 more. So 8 is actually the minimum. Obviously, if you need to load the contact every time it scrolls in, it's going to be slower. But the idea here is that you actually don't need to pre-allocate everything. Java ME has a mechanism, and the Tantalum library, which I recommend everybody to use, has a very good way of caching this. So it doesn't matter how much free memory you have, it will use it, and you will have all your stuff in memory. But whenever you encounter a low memory condition, it will discard the not used parts. This is called weak reference caching. So it's actually a very, very convenient way of dealing with memory. So whenever you have something, usually images, that stuff that you can load in back on from either the flash or the network, you just do it whenever you need it and not keep everything in memory, because we are really, really low on that. So treat the garbage collector as a friend, not as a slave. That's a good advice for Java in general, because people seem to think that the more times they call garbage collection, the better it will work, which is not true. It's pretty much the opposite, but that's how people handle this. All right, there is a number of ways you can do this or help this render caching. Timur there was, I believe, working with fonts the other day, and in Java ME, given how slow text rendering is, so the idea is that if you are going to render it more than once, you want actually to put it on an image, and move that image around. So if you are redrawing the same thing several times, you are doing it wrong. So the worst way to do it is, if you're having a ticker, for example, is to just draw text at every spot as it's scrolling. So that's deadly in terms of performance, but you really want to move your images. So there is a ton of these very little tricks you can do, and I will, because we had a nice little discussion, I will skip over these. But in any case, the message is that you should work with your interaction designer to find your cheat zones, how you can make things look faster if they are not faster, and always try to focus on the interaction with the user. So of course there are technical limits and all that, but the key is how the user feels it should work right. It is a huge market. So I said 650 million devices active, and there is in total, I believe, something like around maybe 2,500 developers that I have knowledge of, maybe more that I don't know of, but in any case, way less than any other platform of even close of that distribution or install base. So I know that my friend, when he was publishing, and he said, like, well, I'm not sure it's Java ME and Asha, and what do I know if it's worth my effort and such. And I said, like, well, do you just your simple app, you have some image view or PDF rendering, whatever, and publish it. And then he calls me back like, this is horrible. I mean, it's not even 24 hours and I have 20,000 downloads, and I don't know what to do with it. I didn't put even the ads in yet. So, sometimes you run into these problems that, you just want to try out things, and it turns out that, it's really a huge install base. So if you do something that is, worth, so it's not just a flashlight, please don't do flashlights. Please, whatever you do, don't do flashlights. But pretty much anything else that makes even remote sense is probably going to be hugely successful. So because exactly of the large install base, so if every 1,000th user downloads it, that's still going to be more than if every single user of pretty much any other platform other than Android and iOS downloads it. All right, if you want to do this, you go to developer.nokia.com. You have all the tools there. They are for free. You don't need to pay anything, which is good. You don't need to. There's a €1 registration for the store, but that's more for just validating your user identity rather than us getting rich on that €1 that you're going to send us. And that would be it on my side. Any questions? Yeah, the same thing. Yes, Nokia Store nowadays. That's how we call it. All right, in that case, thank you very much, and I hope to... All right, thanks, and see you soon, I hope.